Now we shall move into the chapter 4, that is compounds, mixtures and chemical changes. So, we will just a reminder what is an element. So, before going into that, let's think about what is an element. Element is nothing but a single atom. I mean, like it is a mixture of single atom. It contains only one atom. For example, so if you are taking a ball of sodium, okay. So this is an element because it contains only sodium atom. Okay, so that is an element. But on the other hand, a compound. Let's see. I will tell you some of the examples of compound. So see, for example, H2O. This is a compound. Carbon dioxide. This is a compound. C2H5OH. So this is also a compound. Okay, so this is also a compound. Okay, so here actually more than two elements are combining. For example, here actually, in the case of water, see, two hydrogen atoms are combining to form. Okay, so two hydrogen atoms are bonded to oxygen. Okay, so this is a compound. And here, for example, for carbon dioxide. Okay. So this is a compound because two oxygen atoms are bonded to carbon atom. So here this carbon dioxide, it contains two atoms, and water it contain two atoms. So two hydrogen atoms are bonded to oxygen atom. So this is an example of compound. Okay. So a compound, it contains more than one atoms. It is bonded together. So which you will come to know in your successive classes. Here actually the oxygen and hydrogen are bonded, so we call this bond as a covalent bond. Okay, covalent bond. And here carbon and oxygen are bonded, so we call it as covalent bond. Okay, so here you can see actually here two represent, right? Two, it represents how many number of hydrogen atoms are there. On the other hand, you can see here in carbon dioxide, here the 2, subscript 2, it is just below the oxygen atom. That signifies, like two oxygen atoms are, two oxygen atoms are there in carbon dioxide. Again, you can see here in methanol, C2H5OH. So here two carbon atoms are there, and 5 hydrogen atoms, it is bonded to carbon. So if you write methanol, it shall come in this way: 1, 2, 3, again another carbon, 3, 4. Okay, so here this is how the ethanol it comes. Okay, 1, 2, 3, 4, 5. So hydrogen atoms, actually 3 hydrogen atoms are bonded to this carbon. Again 2 hydrogen atoms are bonded to this carbon. And this hydroxyl group, it is bonded to this carbon atom. Okay, and so this is an example of ethanol. And here how many number of carbon and how many number of elements are present, that we can see here. And 2 carbon atoms, 5 hydrogen atoms, 1 oxygen atom. Again, this is actually a functional group. OH group, it is actually a functional group, what we call it as a functional group. Okay, see, compounds, again one of the commonmost compound is NaCl. Here sodium atoms, Na plus ions, it is bonded to Cl minus ions. Okay, so here this is again an example of compound because it contains 2 atoms. Okay, so like compounds, it contain more than one number of elements and which is bonded with some particular bond. Now we shall see the difference between compounds and mixtures. See, mixture, it contains more than one components. For example, you take a beaker, you take a bowl. So okay, so it contains what can I say? So this is salt, sodium chloride. So let this be the sodium chloride. This be the sugar. Okay, so this is an example of a mixture because it contains 2 components, right? One is sodium chloride and next one is sugar. So the same way, the mixture it contain, if it contain more than one component, that we can call it as a mixture. And you take a Petri plate. So this contain sulfur, and this is actually iron. So you are taking a Bunsen burner. You just to boil this the spatula or like iron rod. You are taking an iron rod and you are boiling it. So and if you just put that Bunsen burner into this mixture which containing and iron and sulfur, okay, what you can see is a bright and intense light it shall be forming. Okay, bright and intense light it shall be forming. So and you will see that some bright and intense light it shall be forming, and that is after some time you are just observing that. So you will see that like some dark color, I mean like some black color powdery substance it would be forming here. Okay, so this is if you are observing, this could be iron sulfate, because when you give a intense light, I mean intense energy, this iron and sulfur it react to form FeS. Okay, so this is actually iron sulfate. Okay, this is nothing but an iron sulfate. And now this bright and intense light, actually for formation of iron sulfate, we can give some intense light actually in the form of energy. So this energy we supply, and that energy it absorbs, this iron and sulfur it absorbs and form iron sulfate. That is nothing but the product. Okay. This reaction, what has happened, reaction between iron and sulfur, it is forming iron sulfate. It is a chemical reaction. Let's see the symbols of a chemical reaction. See, like if I write this reaction, you can write Fe plus S, it gives FeS. So here, this positive sign, it shows that, there's both the products actually, let it be A and B, it is reacting. It is actually combining each other, or it is reacting. This arrow sign, it shows that, which is giving the product. Okay. So that is what the arrow shows, and this one is it is giving the I mean like both iron and sulfur, both are the reactants. Okay, and now yeah. So in this reaction, when it was happening, see like iron and sulfur. So when it is actually in order for forming the product, a bright and intense light it you need to give, bright and intense light you have to give, and that only when you give a energy, only when you are giving energy, this reaction shall takes place and give rise to FeS powder, and okay, only when you give the intense light, only when you give the energy inside, the reaction will form Fe plus S, and it gives FeS. Okay, so this is a black color powder. Of course, I am, most of the reactions, whenever a reaction is happening, it shall give a, I mean like either it will be absorbing energy or it will be releasing energy. So any reactions, when it is happening, if it is absorbing energy, it will be, you can say it is endothermic reactions. If it is a releasing energy, we can say it is exothermic reactions. Exo means giving out, endo means taking inside. So here actually, in fact, this when we are putting this iron rod, which is I have shot into the flame, and then like and I am keeping here, I am supplying energy for this particular reaction. Okay, so this is the reality, and see, usually once you can easily convert this iron and sulfur to FeS. Okay, but the reverse reaction, if you just heat it, if you are heating this iron sulfate, ferrous sulfate, or like if you are just putting it into solution, doesn't mean that it will separate into iron and sulfur. Once a chemical reaction happens, then it is very difficult to reverse it back. Of course, it is possible. It is possible to reverse, but not with usual method like boiling or like shaking or like filtering. These kind of processes doesn't solve this chemical reaction. Once a chemical changes happened, okay, that is permanently happened, and you need to have again further chemical steps to reverse the process. Okay. You may tend to ask what is the difference between a physical reaction, physical process, and chemical process. What is the difference between a chemical process and physical process? See, a physical process is, for instance, you are taking a beaker. So you take a beaker and let this be the solution. So yeah, okay, let it be a watch glass. So this is a watch glass, and it contain sulfur particles and iron granules. Okay, and you put it into some methyl benzene. So like this methyl benzene, I can draw the structure in this way. So this is methyl benzene. So this is the solvent. What it happens is, this sulfur, it dissolves in methyl benzene, because sulfur, it is soluble in methyl benzene. So this particle, the solvent, it contains sulfur. Okay, and this iron granules, iron particle, it will come and settle in the bottom. It will come and settle in the bottom. Okay, and yeah, so now if you pour this into, now you can say it is very easy to separate. See, here no product is formed. Still, if you take this beaker, still this solvent contains sulfur, and in the bottom the iron granules, it will be there. So here, now you can easily separate it out. You just pour it into a funnel, and so this iron granules, it will be coming here, and the methyl benzene, it will passes through the funnel through the filter paper. Here actually this is a filter paper. So this methyl benzene, this solvent, it contains sulfur, and here in this filter paper, that contains iron granules. Okay, so and this iron granules, it will remain here, and sulfur, if you evaporate it, if you are boiling this methyl benzene. Okay, so yeah, okay, I am taking it out, and this is a methyl benzene. So this contains sulfur, and if you are boiling, all this methyl benzene, it will go out. Okay, and the sulfur, it remains after some time, the sulfur, it remains in the bottom. So this is sulfur. Okay, so this is how the reaction happens, and sulfur, it remains there, and all the methyl benzene, it will be going out. Okay, so this is what it is going to happen, and you can easily separate sulfur, and through this filtration you can easily separate iron granules. See here, this is a physical process. I just added methyl benzene, which is a solvent, and it will be dissolving sulfur, and I will be easy to I can easily separate iron granules with the sulfur. So what here you need to know is, this is a physical process, because no new product is formed. So still, you have iron granules and sulfur, both are the same products that was before. So in a chemical process, new product will be forming. In a physical process, no new products it shall be forming. So this is the main core difference between physical process and chemical process. Chemical process is irreversible. Once iron sulfide is formed, you cannot easily reverse it back. But for a physical process, it is reversible, because yeah, I just poured this some solvent, methyl benzene. Now sulfur is here in the methyl benzene, iron granules are here. So I can still, I can separate iron and sulfur, iron granules and sulfur. I can easily separate it out. Okay, so this is the thing.